this video, we will discuss more about recursion in Java. We will target a specific problem: how to compute the summation of all the integer numbers between 1 and n. Hi, I am Dr. Shahriar Hossain. Recall from the previous video that we can go over a series of numbers using recursion. In the previous video, we printed the numbers using recursion. In the current video, we will apply mathematical operations like summations over a simple series of integers. Basically, we will be solving an exercise question that I provided in the associated page for the previous video. Notice that the exercise question we are targeting is to add all the numbers between 1 and n. Of course, using recursion. In the problem, it is expected that n is greater than 0. We can write the problem as a series of integer numbers 1 plus 2 plus 3 plus 4 plus continuation of this series up to n. Instead of writing 1 plus 2 plus 3 plus 4 plus up to n, we can just rewrite them as n plus go down to 4 plus 3 plus 2 plus 1. That is, I can write the numbers backward without changing the content of the series. We can put some more values in terms of n here in the sequence. N plus n minus 1 plus n minus 2 plus, then go down to up to 4 plus 3 plus 2 plus 1. Note that n is the largest number in this series. The next number is 1 less than n, which is n minus 1. The number after that is 2 less than n. Therefore, it is n minus 2, so and so forth. Finally, the numbers added become smaller and smaller, such as 4, 3, 2, and 1. We do not add anything smaller than 1 because there is a condition with the problem description that n is greater than 0. That means any number in the series has to be greater than 0 because any number can be considered n since it is the variable to this problem. Let us say that the function that sums up all these numbers is called adder. Adder is a function of n. We write it as the word adder. And then within parentheses we write n. It is easy to write a method to implement this function adder using a loop. Let us write a Java method that implements this adder function. The method that implements the adder function must return a number. In this case, the summation of integers is also an integer. Therefore, the return type is integer. Here is the name of the function. Then, in parentheses, we have the parameter n. Inside the method, we will keep a variable named sum that will add the value of each number between n down to 1. The sum variable starts with 0. The loop variable I starts with n and keeps decreasing by 1 in each iteration. The loop keeps iterating as long as I is greater than 0. Inside the loop, all we have to do is we have to add the loop variable I with sum and keep the summation in the sum variable. At the end of the loop, we return whatever we have in the sum variable. This is the adder method without recursion. Let us quickly write a program class named summation, where the user provides the value of n in the main method. Then the main method calls the method adder with n as the parameter. The sum result is kept in a variable named s. Then the program prints the content of the variable s, which has the summation result. Note from a previous lecture on methods that we have to declare the adder method as a static one because we are calling adder from the main method, which is a static one. Let us save the file, compile it, and run it. The user enters 5 as the value of n. The program prints 15, which is the summation 5 plus 4 plus 3 plus 2 plus 1. The user enters 100 in place of n. The program prints 5050, which is the summation of all the integer numbers between 1 to 100. The program is working perfectly. However, the problem description states that we should not use a loop. Rather, we should use a recursion to solve this problem. Therefore, let us change the method adder in such a way that it does not contain any loop. Here is the sequence we want to code. As explained before, at first we have n. The next number is 1 less than n, which is n minus 1. The number after that is 2 less than n, therefore it is n minus 2, so and so forth. Finally, the numbers added become smaller and smaller, such as 4, 3, 2, and 1. Note that we wrote a method adder n. We want to modify that method to get rid of the loop. We can mathematically say that adder n is equal to this entire series. Now notice that the part that contains n minus 1 plus n minus 2 plus down to 4 plus 3 plus 2 plus 1 can be considered as adder n minus 1. Hence, we can write adder n equals n plus adder n minus 1. Adder n minus 1 already has every term from n minus 1 down to 1 in it. An example based on this equation, adder 5 is equal to 5 plus 4 plus 3 plus 2 plus 1. Based on the same equation, adder 4 is equal to 4 plus 3 plus 2 plus 1. Therefore, we can replace 4 plus 3 plus 2 plus 1 of the adder 5 equation by adder 4. That is, we can write adder 5 is equal to 5 plus adder 4. Now, the general equation is adder n is equal to n plus adder n minus 1. Notice that it is already a recursive equation. In the left side, we have the function adder with parameter n. In the right side, we have the same function adder but with a smaller parameter n minus 1. Notice that the problem description already states that n should be greater than 0. That means if the recursion ever reaches to a parameter 0, we should return something that does not contribute to the summation. Something that does not contribute to a summation is 0. That means no harm is done if we add 0 to anything. Therefore, we will return a 0. instead of further going inside another recursion when the parameter itself is 0. Hence, we have a base case. Let us code the items we discussed. Let us delete the loop entirely. Let us keep the sum variable. The variable sum now should be sum equals n plus adder n minus 1. We are still returning sum, just like when we had a loop. The recursion will do the work of looping. We have not yet written the base case. As we discussed before, we should return a value that does not contribute to the summation when we see a number smaller than 1. If we find that n is smaller than 1, we will directly return 0. We write if n is smaller than 1, then within curly brackets we write return 0. We are done with the code. Let us save the file, compile it, and run it. The output remains the same as before, just like when we had the loop. Let us quickly trace the program using my tablet. I suggest that you too use paper and pencil to trace your code. Let us trace the program for n equals 3. That is, the user entered 3. N in the main method is 3 now. In the line s equals adder n, the right side of the equal symbol will execute first. That is, we jump to the method named adder with a parameter content of 3. N in the parameter is 3. We go inside. If n is smaller than 1, that is, if 3 is smaller than 1, is a false statement. Therefore, we directly jump to the line where the variable sum is initialized to 0, and then we go to the line that contains sum equals n plus adder n minus 1. The right side is executed first. That is, n plus adder n minus 1 will execute first. Note here that n is 3. Therefore, it is sum equals 3 plus adder 3 minus 1. 3 minus 1 is 2. Therefore, we call the adder method with a value of 2. We leave the method adder where n was 3 to a method which has the same name, adder, but now with parameter 2. Inside the new method in the if statement, if n is smaller than 1 is read as if 2 is smaller than 1, which is false. Therefore, we directly jump to the line where the variable sum is initialized to 0, and then we go to the line that contains sum equals n plus adder n minus 1. Note here that n is 2. Therefore, it is sum equals 2 plus adder 2 minus 1. 2 minus 1 is 1. Therefore, we call the method adder with a value of 1. We leave the method adder where n was 2 to a method which has the same name, adder, but now the parameter is 1. Inside this new method in the if statement, if n is smaller than 1 is read as if 1 is smaller than 1, which is false. Therefore, we directly jump to the line where the variable sum is initialized to 0, and then we go to the line that contains sum equals n plus adder n minus 1. Note here that n is 1, therefore it is sum equals 1 plus adder 1 minus 1. 1 minus 1 is 0, therefore we call the method adder with a value of 0. We leave the method adder where n was 1 to a method which has the same name adder, but now the parameter is 0. Inside the new method, in the if statement, we have 0 is smaller than 1, which is true. Therefore, we go inside the if statement now. Now we have the statement return 0 inside the if statement. We leave this method with a value of 0. We go back to the method where the value of n is 1. We are in this line sum equals n plus adder n minus 1. We just returned from adder 0. Adder 0 returned us 0. Therefore, adder 0 is replaced by 0. This 0 is now added to 1. Therefore, the right side sums up to 1. 1 is copied to the left side, where we have the variable sum. The variable sum is now 1. We go to the next line, where we have return sum. The value of sum is 1. We leave this method with a return value of 1. We go back to the method where the value of n is 2. We are in this line. We just returned from adder 1. Adder 1 returned us 1. Therefore, adder 1 is replaced by 1. This 1 is now added to 2. Therefore, the right side sums up to 3. 3 is copied to the left side where we have the variable sum. The variable sum is now 3. We go to the next line where we have return sum. The value of sum is 3. We leave this method with a return value of 3. We go back to the method where the value of n is 3. We are in this line sum equals n plus adder n minus 1. We just returned from adder 2. Adder 2 returned us 3. Therefore, adder 2 is replaced by 3. This 3 is now added to the value of n, which is 3. Therefore, the right side sums up to 6. 6 is now copied to the left side, where we have the variable sum. The variable sum is now 6. We go to the next line where we have this statement, return sum. The value of sum is 6. We leave this method with a return value of 6. Notice that we have returned back to the main method. We replace adder 3 with 6 that was returned by adder 3. Therefore, the variable s will receive 6. In the next line, we print the content in the variable s, which contains 6. 6 is printed on the terminal. The program terminates as the main method ends. Note that we finally received 6 for a call to adder 3 because the recursive call eventually added 3 plus 2 plus 1 plus 0. This series 0 was returned by the last call, but it does not impact the summation at all. The summation is 6. In the tracing of the program today, you have noticed that n had different values in each call. As I said earlier, many sophisticated algorithms in artificial intelligence rely on recursion because recursion automatically saves the local variables and the parameters in each call. Recursion is an elegant technique. The reality of recursion is that you will prefer an iterative solution over a recursive one if the iterative one is easy to code. Sometimes the recursive solutions are easier to code, but can be slower than iterative solutions. The trade-off between ease of coding and how fast your program runs is a topic that is generally discussed in an algorithms course. The specific topic is known as algorithm complexity. Maybe someday we will discuss about algorithm complexity too. For now, let us keep practicing and developing our programming skill. If you liked this video, please press the thumbs up icon. If you have not yet subscribed to computingforall.com and to this YouTube channel, please do so to receive notifications on our new articles and videos. Hope to see you soon in another video. Thank you.